Good day everybody. This is an interesting question and I will have to draw the figure. Let me draw the circles. Circle 1, circle 2, three, you got the fourth one. Okay, so this is the center and you got centers for these circles. And we have a huge circle which is actually covering these circles. Now the challenge is to get that figure. I'm not sure if I will be able to get it. So if I were to draw freehand, it will look a little bit. Let me try my best of drawing okay, it's somehow it is coming. Let's see. Okay, and then we got one more major thing. Okay, so this is a circle, right? Because of the lack of equipments, we need to adjust with whatever apparatus we've got. So successfully the circle is drawn. Now these are the information that has been given. What is that? The large circle. The large circle is 12 units. 12 units in radius. Okay, now we are expected, if you see this figure in the question, we are expected to find this area and there is an arc here. Okay, there is an arc which is actually equidistant from the center. So this is an arc that is being given in the figure and we are expected to find this area along with this area. So that means the total shaded region. Now what I wish to do is, since the arc is equidistant from the center, I will utilize this arc in completing a circle. Okay, so this is a circle and this is the arc that is given. So the question wants us to find this area, and this is a beautiful question, right? So foremost, what I wish to do is, I would like to take all these circles are equiradius. Okay, equiradii. Okay, this is given, and let me take the radius of the circles to be equal to r unit. Circle 1 is r, circle 2 r, r. So all of these are r units. Now let me take the radius of the central circle. This is a central circle. Central circle to be equal to some y. Now what I wish to do is, I would like to draw a line from the first circle center to the second circle center. Now according to the theorem, if I were to connect these centers, then that line would pass through this line of contact of these circles. So there is a property. So you might be asking, how is it is intersecting, or how is the line passing through the point of contact? Because of the fact that if by the theorem, by the circle theorem, if I were to connect two circles at their centers, and if these two circles are touching, then the line that is used to connect these two circles will pass through the point of contact. Okay, so I know that this is R and this is R. That's going to come in handy. Now what I wish to do is, I would like to draw a line from this center to this center to this point, and you can clearly see that that line would be connecting all this. Okay, that line would be connecting all the 3 points. Now if I were to do that, let me connect the points. So I'm connecting the first point with the second point, and the second point with the third point. I can do that, but if I were to do that, that would confuse the figure a little bit. I just don't want to do that. Now for the time being, let me take this radius to be as y units, this is r units. Now what I wish to do is, I would like to connect this center with this center. Alright, now just visualize this, let me just connect this and then I will explain to you. Now I am just saying this is going to be 90 degrees. Now why is that going to be 90 degree? Now watch here, if you were to drop a line like this, that is actually connecting the center of this large circle, right? That line is actually drawn through the center of the large circle and it will hit a point over here. Now similarly, if I were to draw the line from the center of the large circle in this fashion, connecting these 3 points, that would mean the line that we are drawing is actually intersecting perpendicularly. So they would make an angle of 90 degree. That's exactly what I want to bring it to your attention. So since they are making an angle of 90 degree, I can use the Pythagoras. So this is going to be y units, this is going to be r units. So if I were to take this as C1, C2, this is C3, C4, and if I were to take this point as some O, then clearly by Pythagoras, OC2 squared plus OC1 squared is equal to C1 C2 squared. Now OC2 is y plus r, so y plus r raised to the power of 2, OC1 y plus r raised to the power of 2, C1 C2 is r with r, because I've taken r to be the radius of the small circle, so it's going to be 2 times r raised to the power of 2. Fair enough, right? So this is 2 times of y positive r raised to the power of 2, this is 4 times r squared, 2 divides 4 twice, so I get y plus r raised to the power of 2 is equal to r squared with a 2 there. If I want to move the square root to the other side, I will get root 2 and I will get an r, I will get y positive r. This is what I've got. I can rewrite this as y is equal to, I can take r out, so this is root of 2 negative 1. So this is a beautiful equation that we have got. Let me name it as 2. Now you might be wondering, what is 1? Now the radius of the large circle is 12 units. So that would mean if I were to stretch this line, I can easily see a system in place. So what is the system? If I were to stretch this line, okay, this line is actually traveling from the center to the end. Okay, so let me give a dash line. So from the equation, if I were to take this point as say some p, OP is equal to, let me write this down, given, what is given? OP is equal to 12 units. But what is OP? This is actually R. OP is nothing but R plus y. So R plus y is equal to 12 units, right? So this would mean y plus 2 times R is equal to 12 units. If I were to get the value of y, then y is equal to 12 negative 2 times r. So take this is 1, right, because it's given in the question. Take this 1 and you substitute it here. So therefore I can rewrite 2 to be as 12 negative 2 times r is equal to r of root of 2 negative 1. This can be rewritten as r times root 2 negative r. I move this 2r to the other side, it become positive 2r. I add these two things, I will get an r. So this is r of root 2, and this is a positive r, right? So it's positive 1. So root 2 positive 1. So that's a good value, and I've got a 12 here. So if you were to get the value of r, therefore r value is going to be 12 divided by root of 2 positive 1. This is the value of r. Now take the value of r and you substitute it here. So that would mean I can get the value of y. Okay, since y is equal to r times of root 2 negative 1, and I know the value of r, which is 12 over root of 2 plus 1, I got a root of 2 minus 1. I can rationalize this by multiplying by root of 2 say minus 1 divided by root of 2 minus 1. So this is going to give me 12 times root of 2 negative 1 raised to the power of 2. This is root of 2 squared negative 1, which is going to give me 12 times root of 2 negative 1 raised to the power of 2 divided by root of 2 squared is going to give me 2. 2 negative 1 is 1. So I got a value 12 times root of 2 negative 1 raised to the power of 2. This is my y. Okay, so I've got my y, I've got my x. This is the radius of the small circle. This is the radius of the small circle, and we've got that. And we also got the radius of this circle, the medium circle. We've also got that. Now the question wants us to obtain this region. So how are we going to obtain this region? So let me show that to you. Now, as I mentioned to you, I will be drawing two lines like this. I am drawing a line like this, and then I am stretching this line like this. Now this line is hitting the center, it's passing through the center, right? And then I am drawing another line which is actually passing through the center of the large circle, and it's hitting these points in this fashion. Okay, so the intersection of these two lines will make an angle of 90 degrees. So this angle is 90 degree, right? This angle is 90 degrees. Okay, fair enough. Now this angle is 90 degree. 90 degree will also be made in the smaller circle. So there is actually an arc that is given here. So you can clearly see there is a sector here and there is a huge sector here. Now I want to get the shaded region. Now before I could get the shaded region, what I wish to do is I would like to represent the formula for the shaded region. So to get the shaded region, what I should do, from the sector I need to subtract this small sector. If I were to take this as OAB, okay, OAB is a small sector, and then I need to remove the area of the circle. I need to remove this area and I need to remove this area, right, from the bigger sector. If I were to take the bigger sector as OLM, okay, large sector, OLM. So let me write the formula. So the area of shaded region is equal to sector OLM. From OLM we subtract the area of the first circle. We need to subtract this area of this first circle. So area of C1, that has to be subtracted. So I take out this one and then I take out the third circle area. I need to take out this one. So minus area of C3. So C3 is gone. And then I will also have to take out the sector OAB. So minus area of sector, what is that? OAB. So many things we need to take off. Okay. So first we will have to calculate the area of the sector, the OLM. So what is that area of the sector? Area of the sector formula, let me write that down. Sector OLM is equal to theta divided by 360 times pi r squared. So this is equal to, my theta is 90 degree. I just mentioned to you that there is a 90 degree made over here. So that's 90 divided by 360 times pi times r squared. What is r squared? From the center we are having this distance. So this is going to be 12 units. Okay, so 0, 0, 9 divides here 4 times. So this is pi times 4 and 12 squared. So 12 into 12. 4 divides 12 3 times. 3 times 12 is 36 pi. So this major sector is 36 pi. So let me write that down. 36 pi. Now area of C1. I need to go to a new page. Let me utilize this page. Okay, area of C1. So what is the area of C1? Area of C1 is equal to pi r squared, right? This is a semicircle. So that means half times pi times r squared. But what is my value of r we have got? R is 12 over root of 2 plus 1. So that's nothing but 1 over 2 times pi times 12 over root of 2 plus 1. This has to be raised to the power of 2. So if you raise to the power of 2, this is going to be, I can rewrite this as 12 into 12 times pi 1 over 2 divided by root of 2 plus 1 squared. I'm not going to touch anything with the root of 2 plus 1 squared, but this I can reduce. So 2 divides here 12 6 times. So 72 pi divided by root of 2 positive 1 raised to the power of 2. So this is one value. Now the area of this will also be the same thing, right? Because this radius, right? This radius is going to be the same r. So we have got that value. So now we need to get the area of the sector OAB. So let me do that. Area, so this will also be equal to area of C3. So now I'm going to find the area of sector OAB, which is nothing but theta divided by 360 times pi r squared. The angle is 90. 360 times pi into r squared. My value of A, or I should say value of y. So let me go and locate the y value. Okay, I need to get the y value. So I need to substitute it over here for y. Apparently I got to locate the value, but okay, y is got. I got the value for y. So let me use the y value. Y value is over here, right? So that's my radius. So if I were to substitute that, right? So this is r squared already. My y, let me write that y. Y is equal to 12 into root of 2 negative 1 raised to the power of 2. This is my radius. Now if you want, you can simplify this and substitute it here. If not, you can substitute it directly. So this is going to be 12 times root of 2 negative 1. There is a degree 2 here, and this is raised to the power of 2. So this is what you got. So you reduce this, 9 divides here 4 times. So pi over 4. 12 squared, I can write it as 12 times 12 times root of 2 negative 1. This is degree 2. So this will become degree 4. 4 divides here 3 times 36 pi times root of 2 negative 1 raised to the power of 4. So this is what you got. So now go back to the formula. We need to subtract all of this. We need to put back and then simplify. So area of C1 is 72 pi divided by root of 2 squared, root of 2 plus 1 squared, again 72 pi root of 2 plus 1 squared minus, this is 36 pi times root of 2 negative 1 raised to the power of 4. So this is what we've got. We got to simplify this. So let me show you the simplification. So 6 pi, and then I will take 72 pi out of this. I will evaluate this separately. So 1 over root of 2 positive 1 whole squared, positive 1 over root of 2 positive 1 whole squared. So this is one value, and then negative 36 pi root of 2. This is root of 2 negative 1 raised to the power of 4. Now of course you can rewrite this as 36 pi negative 72 pi is going to be 2 over root of 2 positive 1 raised to the power of 2, negative 36 pi of root of 2 negative 1 raised to the power of 4. Now root of 2 is 1.414, utilize that value. Now this is equal to 36 pi negative 72 pi, 2 divided by, this is going to be 2.414 raised to the power of 2, negative 36 pi, you subtract 1 out of it, you get negative 0.414 raised to the power of 4. Now you can utilize your calculator. Let me use the calculator and find out the value. So this is 36 pi negative 72 pi, 2 divided by 2.414 raised to the power of 2. I'm utilizing the calculator. 2.414 squared, that gives me 5.827. I'll take it as 5.827, and 36 pi, 0, this negative sign and degree even, it doesn't matter, so just take 0.414 and you raise it to the power of 4. This will give you a value of 0.0294, and that's fine. So now you divide 2 by 5 point. So let me do that. 2 divided by 5.827. 827. So that's going to be 0.3432 multiplied with 72 pi negative 36 pi, and you got 36 pi times 0.0294. Now what I wish to do, I would like to take 36 pi out. If I do this, I get 1 negative, there's going to be 2 there, so 2 multiplied by this quantity is going to be 2 to the 4, 3 to the 6, 8, and 3 to the 6, so it's going to be 0.6864, and you got a pi is already taken out, so 36 is already taken out, 36 pi is already taken out, so it's going to be negative of 0.0294. So what we need to do, we need to perform the calculations. So I can just do it over here. 0.6864 added with 0.0294. This is 8, 15, 11, 7, 0.7158. So from 1.000 I have to subtract 0.7158. So there's going to be 2949892 and 0.2842. This has to be multiplied by 36. So I have to use the calculator now. 0.2842 multiplied with 36. So what do I get? I get approximately 10.2312 pi square units. So this is the area of the shaded region. Thank you everybody. Please subscribe, like and share the video. Until we meet again, enjoy your day.